Hello guys, welcome back to my channel. Today I'll be discussing four fundamental laws of thermodynamics. So what is thermodynamics? Thermodynamics is a Greek word. It means it means heat. Dynamics, it means motion. So heat motion, or you can tell that it is a that interconversion of energy with each other. Okay. It provides framework of understanding and analyzing behavior of a system. So thermodynamics, actually the study of transformation of energy, enables us to discuss all these matters quantitatively and to make useful predictions. So I'll be telling simple example where we apply the thermodynamics concepts. Here you can check that whatever the electrical energy is there, when the fan rotates, that electrical energy is converted to the mechanical energy. Okay. Similarly, in the batteries, the potential energy of that chemicals, okay, that converted into the electrical energy. Similarly, here you can check that in the nuclear power plant, the nuclear fuel, which has the enormous potential energy, is converted into the electrical energy. In the coal power plant, the coal when you burn, then it transfers into the heat energy, and that heat energy boil the water, and that turbine rotates by the steams, and that convert into the electrical energy. So how that one energy is converting to the other energy? So actually thermodynamics deals with it can tells. Okay, there are four fundamental laws of thermodynamics. One is the zeroth law of thermodynamics, first law of thermodynamics, second law of thermodynamics, third law of thermodynamics. Okay. So what is the zeroth law of thermodynamics? Actually, zeroth law of thermodynamics tells about it actually defines the temperature of a systems. So when that first law and second law of thermodynamics is discovered, that time actually no one can define the temperature. Okay, and the temperature actually unknown parameter, okay, in the time. After that, so they formulated the zeroth law of thermodynamics. So what is the zeroth law of thermodynamics? They are saying that if two systems, okay, suppose system A and system B, they are in thermal equilibrium with each other, and suppose the systems A and C, they are in thermal equilibrium with each other, then you can tell that B and C, they are in thermal equilibrium. So if two systems are in thermal equilibrium with a third systems, then they are thermal equilibrium with each other. You can tell that if A equal to B and A equal to C, then B equal to C. So zeroth law of thermodynamics actually can tell about the temperature scale, or it can tell which one is the hotter object, which one is the colder object, and how the heat will flow from the which system to the other systems. Okay, so it can tell us about. Okay, then I'll be coming to the first law of thermodynamics. So what is the first law of thermodynamics? First law of thermodynamics actually tells the law of conservation of energy. What is the law of conservation of energy? So if you think the world is an isolated systems, and if you think so the energy whatever that is there in the world, it is a constant. Okay, the energy of an isolated system is constant. Or you can tell the energy can neither be created nor be destroyed. It can only change its forms, okay, from one system to the another systems. Okay, it can transfer from one system to the other systems. So you mathematically, if you express this equation, then you can tell that the change in internal energy of a systems equal to heat added to the systems and work done on the systems. So delta U equal to Q plus W. But if the system work, okay, do the work, then you can write Q minus W. Okay. So since the system has done the work, you can write Q minus W. So delta U equal to Q minus W. So actually the first law tells about the internal energy and how this internal energy can be, okay, converted into the heat and work. Or when you supply heat, how it can change the internal energy and how the work is happen. Okay, so that can define about that. Okay, now I will be coming to the second law of thermodynamics. What is the second law of thermodynamics? Second law of thermodynamics actually tells about the spontaneity. Okay, so it can tell us about that any natural phenomena which is happening naturally. Okay, so some things happen naturally. Suppose if you have the cold object and if you have the hot object, when you contact hot object to the cold object, then heat will flow from hot body to the cold body. Similarly, many chemical reactions happening naturally. Like suppose we are getting older, so all those chemical reactions are happening naturally. Okay. Similarly, our hair is getting gray, black to gray. So black to gray, it is happening naturally. Okay. It can tell us about the spontaneity of the reactions or directions. Okay. Actually, that most of the so according to the second law, so the reactions are irreversible. Many reactions are irreversible. Okay, so reversible is not possible. Okay, however, some of the cases you can do the reverse reactions. Okay, so it means like when you are doing the electrolysis of water. Okay, or maybe you are cooling some object. Okay, in the refrigerator. So you are actually working on the systems. So this is also possible by doing work onto the systems. Okay, so that, but that how much spontaneous or what is the rate of the reactions, the second law cannot tell. So here I'll be telling, like, conversion of diamond to graphite. It takes actually longer time. Okay, so that is the reason you will be never knowing how when the diamond will change to graphite. It is such a slow reactions. The reaction is spontaneous reaction, but it is extremely slow reactions. Okay, but when you take some the gas and you are keeping to the vacuum, okay, so instantaneously the gas expansion is going to happen. So this is a spontaneous instantaneous reactions. So the second law of thermodynamics, it cannot define the rate of the reactions. Okay, it can tell about the entropy, spontaneity. Okay, all those things it can define. It can tell us about also entropy of the systems. Okay, so entropy of an isolated systems always tends to increase over time. Entropy is a measure of disorder or randomness in systems. This law also introduced the concept of irreversibility and directionality of process such as heat flow from the hot to cold object. Okay, so this actually also tells about the entropy of the systems. So what is the entropy? Entropy means actually randomness, okay, or chaosness. If the randomness or chaosness of the molecules increases, it means the entropy will increase. If the entropy increase, the process is spontaneous. Okay. So you can, I'll be giving some example here. Suppose you are you are keeping some bouncing ball into the floor. Okay. So when it actually hit, to the floor, so it will little bit higher. It will go again. It will bounce, and after few bouncing, so it will just go to the rest. Okay, but the reverse things is never is going to happen. So what is happening, whatever that motions, or maybe the heat or whatever the energy is coming to that, and they are hitting to the floor, so that heat or energy they are converting into the small microparticles into the floor, and they're dissipating all those energy into the floor particles. The second, so that this is the reason the first bouncing, whatever the height as it falls, it will never come to that height. Okay. Similarly, the second bouncing, so again this thing happen. Third bouncing, again this thing happen, and at last they are going to become rest. So that this thing is going to happen, and energy is getting dissipated into the floor particles. Okay, but if you want to do the reverse, like any rested particles, it will never jump, or it will never bounce. Okay, so that thing is not going to happen actually without doing any work. It can tell about two statements also, like one is the Kelvin statement and one is the Clausius statement. So what is the Kelvin statement? The recognition of the two classes of process, spontaneous and non-spontaneous, is summarized by the second law of thermodynamics. This law may be expressed in a variety of equivalent ways. Like one statement was formulated by Kelvin. So what is the Kelvin statement? So he said that no process is possible in which sole result is the absorption of the heat from a reservoir and its complete conversion into work. Like suppose you want to convert all heat into the work, it is never possible. It is highly impossible actually to construct an engine whose sole effect all the that heat conversion into the 100% work. This means all real heat engines have both, they have the hot source and they have the cold sink. So whatever the heat they will absorb from the hot source, So that energy they actually cannot convert into the 100% work. So some of the heat will be discarded into the cold stream as heat. So so it can tell us about that heat can flow from the hot to the cold object indirectly. Okay, and what is the closest statement? So closest statement tell that no process is possible whose sole results is the transfer of heat from a colder object to a hotter object. So no process is possible whose sole results in the transfer of heat from a colder object to hotter object. Means heat cannot flow from the cold object to the hot object. Okay, so this is about the closest statements. If you want to send some this kind of things, so it is highly impossible. Okay. Also, the second law of thermodynamics can tell us about the spontaneity of the reaction. Already I told. So, like suppose if you take the ice cube, okay, and it actually melt, it naturally it melts into the water. Why? Because the whatever that the particles, that microstates are there, okay, so they actually get the random motions into the water, okay. So randomness or chaosness of this particle increases into the water, and this is the reason the entropy will increase, and when the entropy will increase, that process will be spontaneous. Okay, but when the reverse you do, the entropy of the system should decrease. So you have to work on that water and to make the ice cube. Okay. Also, it can tell us about the dissipation of energy. Already I told. Like suppose you have the solar energy, okay, that is coming to us as in biochemical, okay, from that food chain and food wave to us, but it is getting fixed by the all the plants. Okay, so plants actually making the photosynthesis, and they are doing, they are converting all the solar energy into the photochemical energy. Okay, and then in the 10% energy is coming to us. Okay, that first tropic level, then the second tropic level, and third tropic level. But 90% energy is getting dissipated as a heat into the environment. So dissipation of energy is happening in every tropic level. So 100% transfer is not happening here. So that actually tells, or that actually defines the second law of thermodynamics. Then we are coming to the third law of thermodynamics. Third law of thermodynamics also tells about the entropy of the systems. So it is telling that at absolute zero temperature or 0 degree Kelvin or minus 273 degrees centigrade temperature. So entropy of that any systems that actually approaches minimum value. Okay, this law provides insight into the behavior of matter extremely low temperature and establishes the concept of absolute zero. So the entropy of a pure crystalline perfect substances, okay, so their entropy will be the zero. So here you can see that, okay, this is a perfect crystalline substance and all the atoms in the proper arranged, okay, they are all arranged in the proper way. So this is the region, there is no motions into these particles, okay, since they don't have any motions. So the number of microstates is 1. We can keep the formula S equal to KLN, okay, W is the number of microstate. So T at absolute 0, S equal to 0, okay, entropy of the system will be 0. And but when you heat up this substance, okay, so the whatever the particles are there, so they are going to get the motions, and the entropy of the systems will increase. Similarly, here solid to liquid to gas, the motions of the particle will increase, okay, the entropy of the system will increase. But the reverse one, the entropy of the systems will decrease. So this is about the third law of thermodynamics. So hope guys all the concepts, all the laws are clear. Okay, concepts about laws are clear. And thank you for listening to me.